Hello everyone, welcome to my chemistry channel B.L.DASH Short and Sweet in Chemistry. Now, already I have explained the chapter Redox reaction of 11th class. What is redox reaction? What is oxidation reduction? And what is electronic concept of redox reaction, oxidation and reduction? Now, in this case, I am going to explain the redox reaction for 11th class. The part is 4. In part 4, I am going to explain what is meant by oxidation number and valency, how both are related in a reaction. When reaction is not proceeding and when the element is in native state, we can say that is valency. Valency means combining capacity. It has no charge. It shows only how many times it will combine with hydrogen, chlorine or double of oxygen. Now, when we say oxidation number in a reaction, what is the meaning of oxidation number? Because the reaction is proceeding, product is formed. And here let us see one simple reaction I am going to show you. Hydrogen, you know hydrogen is gas, chlorine is also gas. That is why I want to express these two in diatomic molecule, because gas elements always represented by diatomic molecule, because the atomic state they are very stable, that is very active, and now the diatomic molecule is stable one. When we take the gas, that is always in diatomic form. So here hydrogen and chlorine, when they will react and form hydrogen chloride, now the reaction is proceeding and product is formed, and lastly it will conclude the reaction is over. Then here, what is the meaning hydrogen H2 0, chlorine Cl2 0? I told H2 mean gas form, Cl2 means gas form, that is diatomic form. But what is meaning of 0? The charge is 0. Charge is 0 means here that oxidation state is 0, or you can say oxidation number. Oxidation number means it is only a state in a reaction. So H2 0, chlorine 0, that means the oxidation state is 0. It is ready. Either it will take electron or it will gain electron according to the nature of that element. Now hydrogen when loses electron, generally hydrogen is less electronegative element and chlorine is more electronegative element. That is why hydrogen can lose electron, not gain electron, but chlorine is a electronegative element. That is why it will accept electron easily. That is why here oxidation takes place. Here oxidation, it is ready to lose electron and transfer electron to chlorine. That means here oxidation takes place. In chlorine, chlorine is ready to accept electron, but from whom? From its neighbor, from its neighbor hydrogen. So hydrogen is has a capacity to lose electron and chlorine has capacity to gain electron. That means one side oxidation takes place, other side reduction takes place. Here oxidation takes place because hydrogen is less electronegative element and loss of electron takes place, that is oxidation. Chlorine, that is here, it is able to accept electron or receive electron or gain electron from hydrogen, is ready to accept electron and forms hydrogen chloride. Now what is the sign here? H plus and Cl minus, because after losing electron the charge changes to H plus, after gaining electron the charge changes to Cl minus. And since according to the balance equation here 2 times chlorine hydrogen are there, that is why 2H plus Cl minus. Then what is H plus Cl minus? Here it shows oxidation state. In a reaction, it expresses here what is the oxidation state, what is the charge or what is the oxidation number. So what is oxidation number? Oxidation number is a state of the element in a compound, but not in native state. if it is native state, it only expresses valency but not oxidation number. Oxidation number only shows when a reaction proceeds or in a compound. When compound is formed in a compound, we can see here plus minus charge is there, and that is called oxidation number. It is only a state. But valency is not a state, it is only simply shows what is the combining capacity of that element with whether chlorine or whether hydrogen or double of oxygen atom. Now here what happens? Electron transfer takes place. From whom? From hydrogen to chlorine. Why? Because it is more electron. It is means chlorine is more electronegative element than is hydrogen. Hydrogen belongs to first group, where chlorine belongs to 17 groups. 17 group elements are very electronegative tendency, and so it has electronegative tendency. Electron transfer takes place from less electronegative element or atom of that element to more electronegative atom of the other element. That means here only possible when less electronegative and more electronegative atoms are there, easily one transfer electron takes place from lower electronegative element to higher electronegative element. Now then question is, what is difference between oxidation number and valency? I told oxidation number means it is a state, oxidation state, how oxidation takes place. One side oxidation takes place means other is ready for reduction, other is ready, other atom of the element is ready to accept electron, to receive electron, or you can say to gain of electron. Now first point here, the number of electron lost or gained in the combined state. What is combined state? That means in the form of compound, when the reaction proceeds and what happens, what is the result? The compound is formed. In the compound state, what is the loss of electron takes place or gain electron takes place? What is the charge you will get, either positive or negative? Positive means oxidation takes place and the positive oxidation state, and negative means loss, gain of electron takes place, and negative charge means that is negative, oxidation state is negative. Let us simply NaCl, because already you know simply sodium chloride, and Na is +1, Cl is -1. Generally when somebody asks what is valency, generally someone can say it is +2, +1, -1. No. Only simply there is no charge for the valency. It shows only combining capacity. Then here what happens? If we say oxidation number, that means what is the number of electron loss or gain, you can say, and that is the charge, positive or negative. And number of, but what is valency? Valency means number of hydrogen or chlorine or double of oxygen atom combined with other atom, that is the capacity. What is the capacity of the combining capacity of an element with hydrogen atom, chlorine atom, or double of oxygen atom? That is known as valency. Or you can say simply valency means combining capacity of an atom of the element in the native state. It has no charge, no positive, no negative. So here one sodium atom can combine with one chlorine atom only. That is why you can say what is the valency of sodium? That is 1, not +1, simply 1. +1 means in the combined state, and that is known as oxidation number. Again see, this is part 4 for 11th class redox reaction, and oxidation number means that is oxidation state of that atom of the element, but not in a native state. When the reaction starts, then already you will count here, you will see here how many electron lost and how many electron gained. According to the oxidation reduction, we can say the oxygen state of that particular atom of that element in the combined state, in the compound form. And since the reaction are going to start, that means it is native state, that is why oxidation number is 0 and chlorine oxidation number is 0. And here only possible lower electronegative element lose electron, and to the high electronegative element, just like hydrogen to chlorine, the electron transfer takes place. And this is the number 1 point difference between oxidation number and valency. Valency means combining capacity with hydrogen, chlorine, or double of oxygen atom. And oxidation number means how many electron loss and how many electron gain in a compound state, or you can say in a combined state. And now again we will see other points of oxidation number. I told the difference between oxidation number and valency. Now the second point for oxidation number and valency, what is the difference? Different for different compound. That means oxidation number different for different compounds. It may be same or also for different in different compounds. May be positive or negative, or also may be 0 or fractional number. When it is 0, in uncombined state, in free state, the oxidation number of each element is 0. And valency, regarding valency, it is always fixed one because it is a combining capacity. That is why it is a fixed one. But for a few elements, it is variable, just like transition metals, and it has no charge. Generally, student can say yes, it is +2, -1, 0, something, but actually what is the correct one? There is no charge. It is a whole number. You can say 2, 3, 4 like this, but not any fractional number. Again, see, an oxidation number is different for different compounds, and also it may be a positive, negative, or 0, or maybe a fractional number, whereas it is valency is a fixed value. It is a whole number. It is only variable for few elements, and it has no charge. Now, what are the rules for oxidation number? It is clear now the difference between oxidation number and valency. But what are the rules? What are the rules for the oxidation number? How can you find the oxidation number, and what are the rules? First point, free or uncombined state. What is free or uncombined state? When there is no reaction takes place. When you can say sodium metal, chlorine gas, that is called free uncombined state, or you can say native state. When it is that one, there is no charge. There is no charge, and that is a whole number. When that means in native state, before combination with the others, or uncombined state, the value is 0. Example, chlorine, oxygen, sodium, magnesium, the value is 0. Now for ions, suppose in the form of compounds, in the combined state, they are known as ions. The oxidation number, what is the oxidation number here? What is the charge of that element? That is oxidation number. Suppose Fe plus 3, that means plus 3 is the oxidation number. Let us Na plus 1, plus 1 is the oxidation number of sodium. Similarly, Fe plus 3, that is plus 3 is the oxidation number. Mg plus 2, that is plus 2 is the oxidation number of magnesium. Cl minus, chloride, minus 1, that is here oxidation number is minus 1. Similarly, Na plus, that is here oxidation number is plus 1. That means if it is ions, then you can easily say, you see here what is the charge of the ions, may be positive or negative, or may be fractional, that is the oxidation number of that ion. Now, oxidation number of oxygen in compound, generally the oxidation number of oxygen in a compound, that is generally -2. Most of the compounds having -2 oxidation number of oxygen. But there are some few exception case. Here see, number 1, H2O2. What is H2O2? Hydrogen peroxide. Here you can find this is -2 because hydrogen is +1, so +2, so it should be -2 to cancel each other, and here the value is -1 for oxygen. Now you can see generally we find oxidation number of oxygen is -2, but here it is a special case, exception case, where oxygen is -1. Similarly, KO2, K2O, potassium oxide, but KO2, potassium peroxide. Here you can find, now here +1, so it is -1. So what is the value here? Oxidation number of oxygen, that is -half, because here for 2 it is -1, for 1 it should be minus half. Now in the first exception case you can find oxygen value that is minus 1 and here the value minus half. Second exception case generally with fluorine. We know oxygen fluoride. Oxygen fluoride, then what is that one? Oxygen fluoride. Oxygen is plus 2 and F minus 1 into 2 minus 2. That means here fluoride acts as minus 1 whereas oxygen acts as a plus 2. So the what is the oxidation number of oxygen difluoride? Here plus 2 and oxygen dioxygen difluoride O2F2. Now you can find this is plus 2, this is minus 2 because fluoride minus 1 into 2 minus 2, that is why oxygen should be plus 2. And what is the oxygen number of oxygen here? That is plus 1. Again see, there are exception case for oxygen. Generally here you can find hydrogen peroxide and potassium peroxide. Hydrogen peroxide the value is minus 1 and whereas potassium peroxide the oxidation number of oxygen is minus half. Similarly oxygen difluoride where the oxidation number is plus 2 and here oxygen dioxygen difluoride and here the oxidation number is plus 1 and here you can find the oxidation number and valency difference. It is fixed one, valency always fixed, but it is not fixed, and here the value may be negative, positive or fractional or 0, but here it is always whole number and charge is 0. So what are the rules for free uncombined state? The value is 0, oxidation number is 0. And you can find chlorine, oxygen in a period table. You can see what are the in native state, the value is 0. And for ions in combined state, in compound state, and after reaction the product you see the compounds, and here the charge of that metal, ion or element, any element may be metal or non-metal, you can say that is the oxidation number of that metal or you can say that element. And oxidation number of oxygen generally it is 2 minus 2, but in exception case there are 2 exception case you can find here where it is minus 1 minus half and plus 2 plus half. Then we will see other rules for the determination of oxidation number. As in third point I told the oxidation number of oxygen generally minus 2 and there are 2 exception case already I told. Now you can see oxidation number of hydrogen generally plus 1. You see hydrochloric acid, hydrogen bromide, here you can see the oxidation number of hydrogen is plus 1, plus 1, minus 1, plus 1, minus 1. So here oxidation number of hydrogen generally plus 1, but in exception case let us lithium hydride. You can see this is minus 1, this is plus 1. That means here the oxidation number of hydrogen is minus 1. Similarly calcium hydride, here it is plus 2 and here it is 2 times, so minus 2. For hydrogen it is minus 1. So oxidation number of hydrogen is minus 1. Now these are the exception where you can find the oxidation number of hydrogen is minus 1. Similarly, next point, oxidation number of chlorine. Oxidation number of chlorine, that is 17 group already they are minus 1. And so, but exception case just like sodium chloride you can find sodium chloride where minus 1 plus 1. Now the oxidation number of chlorine generally minus 1. But in perchloric acid here HClO4 you can find the oxidation number of chlorine is plus 7. Now see 4 here charge is minus 2, so minus 8, it is plus 1, so the chlorine is plus 7. Then how can you count here this is plus 7, this is plus 1, minus 8? There is also some rule. What is that rule? Sum of all oxidation number, all the atoms in compound. Now it is a compound, you can find here what is the oxidation number of chlorine. Surely oxygen is minus 2, so you put minus 2 into 4, that is minus 8. and here it is plus 1, and what is remaining? Remaining is chlorine, and you know the sum of all the oxidation number of atoms in a compound should be 0. That means here this is plus 1 plus 7 plus 8, and here minus 8, that is 0. So it is very important once you remember sum of all the oxidation number of atoms in a compound should be 0. Now here you can see other example, KMnO4. Here oxygen is minus 2 into 4 minus 8 and potassium plus 1. So the manganese should show plus 7 of the number, so that the sum of all the oxidation number equal to 0. See here plus 1 plus 7 minus 8 equal to 0. Similarly, you can see different type of compounds. You can find the oxidation number of particular element by adding all the oxidation number that should be equal to 0. Then you can easily find the oxidation number of particular element, particular atom of the element. Now, what happened about polyatomic ion? There are so many polyatomic ions, just like manganate, carbonate, sulfate, nitrite. All they are known as polyatomic ion, where there are so many atoms are present in an ion, that is called polyatomic ion. What happened? The sum of the oxidation number of atoms in the polyatomic ions should be equal to the charge of the polyatomic ion. Let us see Cr2O7. What is Cr2O7? Dichromate ion. What is the charge of the dichromate ion? That is minus 2. Then how can you say here it is minus 2? How can you calculate here chromium oxygen is there? Now for chromium you can find that is plus 6 and 2 times, so it is plus 12. And here oxygen 7 times, so it is 7 into minus 2, that is minus 14. What is the charge of the dichromate? It should be minus 2, because you can count here minus 14 plus 12, that equal to minus 2. So what is the meaning? Polyatomic ion, the sum of the oxidation number of atoms of all the ions. What are the ions here? Chromium and oxygen, and sum here becomes to minus 2, because minus 14 plus 12, that should be equal to minus 2. Similarly, it is known as permanganate ion. What is the charge of the permanganate ion? That is minus 1. Now see, check here. Oxygen is 2. 2 minus 2 into 4 minus 8. Manganese, that is plus 7. And minus 8 plus 7, that is equal to minus 1. So the charge of this polyatomic ion, that is permanganate ion, is equal to sum of the all the oxidation numbers of the atoms here of the different element, that is manganese and oxygen, that should be equal to minus 1. Similarly, is carbonate, CO3, very simple, CO3, and the charge is minus 2. How can you say it is minus 2? How can you satisfy? Oxygen is 2, minus 2 into 3 minus 6, and carbon is plus 4. So you again add minus 6 plus 4 and becomes to minus 2. What is the charge? What is the oxidation number of the carbonate ion? That is minus 2. How can you say? Because the addition of the sum of the carbon and oxygen inside the bracket you can find, and that becomes to minus 2. Similarly, SO4. What is SO4? That is sulfate. What is the charge? What is the oxidation number of SO4? That is minus 2. How can you get minus 2? Because sulfur having charge oxidation number plus 6. Oxygen minus 2 into 4 minus 8. And you sum up the minus 8 plus 6, that becomes to minus 2. So what is the oxidation number of sulfate ion? That is minus 2. And here this is called chromate ion, that is having charge or oxidation number, that is minus 2. Then how can you calculate? Oxygen is minus 2 into 4, that is minus 8, and chromium, that is plus 6, and the sum of the minus 8 plus 6, that becomes to minus 2. So the charge or oxidation number of chromate ion is minus 2. I hope it is clear. Again you see, and here the oxidation number of generally oxygen is minus 2, but there are two exception case, and here oxidation number of hydrogen is plus 1, but it is one exception case where hydrogen source minus 1. Similarly, oxidation of chlorine also minus 1 because it belongs to 17 group, but you can see the example in NaCl where the source minus 1 oxidation number. But there is an exception case, perchloric acid HClO4, where you can find the oxidation number of chlorine is plus 7. And before that, one rule you should know, the sum of the oxidation number of all atoms in a compound should be 0. So you can find, you can see here, oxygen minus 2 into 4 minus 8, and hydrogen plus 1. So chlorine should be plus 7, otherwise the sum never becomes to 0. That is why easily you can find minus 8 plus 1, and that's the chlorine oxidation number should be plus 7. Similarly, other example, potassium permanganate. Oxygen is 4 times, so minus 2 into 4 minus 8, and potassium is plus 1, and we know sum of these oxidation number of all the atoms should be 0. That is why manganese should be plus 7. Always remember, in a compound, the oxidation number, all the atoms belonging here, the sum is always 0. So easily you can calculate the oxidation number of any atom. And here polyatomic ion. What is polyatomic ion? That means a combination of so many atoms of elements where it shows some sign that is positive or negative. And here the oxidation, let us see example, oxidation number of atoms of the ions here, the equal to charge of the polyatomic ion. Let us see, dichromatic charge is minus 2. Minus 2 should be equal to sum of this charge. See here, 7 into minus 2, 14. Chromium, that is 6 into 2 plus 2. 2 plus 6, that is plus 12, and you see sum is equal to minus 2. Permanganate ion, where the charge or oxidation number is minus 1, and oxygen is minus 2 into 4 minus 8, manganese plus 7. That is why the charge or oxidation number of permanganate ion is minus 1. Similarly, carbonate ion, where it is 3 into minus 2 minus 6, and carbon is plus 4. You add to sum of these two digits, that becomes to minus 2. Similarly, sulfate, where it is minus 8, it is plus 6, so the sum becomes to minus 2. So the charge or oxidation number of sulfate ion is minus 2. Similarly, chromate, here 4 into minus 2, that is equal to minus 8, chromium is plus 6, and the sum of all the charges, that becomes to minus 2. Similarly, you can calculate any compound or any polyatomic ion, what is the oxidation number of any atom of the element. Next we will see what is mean stock number. Now we will see how to calculate the oxidation number of an atom in a compound or in a polyatomic ion. Now say calculation of oxidation number. First question, calculate the oxidation number of sulfur in the below given compounds where they contain sulfur. Now H2SO4, that is sulfuric acid, Na2SO4 sodium sulfate, Na2SO3 sodium sulfite. Now see sulfuric acid formula, H2SO4. H means plus 1 into 2 plus 2, and O4 means 4 into minus 2, that is minus 8. So if you take sulfur as X oxidation number, and we know the sum of the oxidation number of all the atoms in a compound is equal to 0. According to that rule, minus 8, this is plus 2, and this is plus X, and that is equal to 0. Then what is the value of X? X equal to plus 6. What is X? That is X is sulfur. So oxidation number of sulfur in sulfuric acid is plus 6. Now next is Na2SO4. What is Na2SO4? Sodium sulfate. Now again you will calculate oxidation number of sulfur here. So Na2 mean plus 1 into 2 plus 2 and oxygen minus 2, that is why minus 2 into 4, that is equal to minus 8. According to the rule, sum of the oxidation number equal to 0. So plus 2 minus 8 plus x equal to 0. So what is the value of x? That is equal to plus 6, and x is mean sulfur. So the oxidation number of sulfur in sodium sulfate is plus 6. Similarly, Na2SO3. What is Na2SO3? Na2SO3 means sodium sulfite. Sodium sulfite, here see oxygen 3. 3 into 2 minus 6 and Na2 plus 1 into 2 plus 2. So according to the rule, minus 6 plus 2 plus x, that is equal to 0. So what is the value of x? Value of x equal to plus 4. That means here the oxidation number of sulfur in sodium sulfite is plus 4. Now you can see the oxidation of sulfur in different compounds are different. This is the calculation of the oxidation number of sulfur in different compounds. Next question. Calculate the oxidation number of nitrogen in below given compounds. First one, HNO3. What is HNO3? Nitric acid. HNO2, nitrous acid. Na3N. Na3N means here sodium nitrite. What is that one? Sodium nitrite. You will find the oxidation number of nitrogen in the given below compound. First HNO3. See, H mean plus 1, O3 mean 3 into minus 2 equal to minus 6, and it's nitrogen X. So the sum equal to 0. So N equal to plus 5. That means X equal to plus 5. That the oxidation number of nitrogen in nitric acid is plus 5. Now HNO2, nitrous acid. What is HNO2? Nitrous acid. In nitrous acid, oxygen 2 into minus 2 minus 4 and hydrogen plus 1 and nitrogen X. So sum of all the oxidation number of atom in nitrous acid equal to 0. So here minus 4 plus x plus 1 equal to 0. When you calculate what is the value of x here, that is plus 3. That means here nitrogen is oxidation number of nitrogen is plus 3. Similarly, Na3N and here it is minus 3, it is plus 3. So automatically you can say it is x. First you write x, then what is the value of here? The value is x equal to minus 3. That means here nitride is x equal to minus 3, and that means nitrogen oxidation number is minus 3. And now you see here they are all plus sign, but here it is minus sign. So the minus 3 because here plus 3 and plus 3, sum of the oxidation number and minus 3 equal to 0. So plus 3 minus 3 equal to 0. So you can write also x here. So x equal to minus 3. So now clear? Here nitrogen, the oxidation number of nitrogen is different compound. HNO3 it is plus 5, HNO2 it is plus 3, and Na3 and sodium nitride, that one N equal to minus 3, because plus 3 minus x equal to 0. X. So plus 3 plus x equal to 0. So x equal to minus 3. And so plus 3 plus x equal to 0. So x equal to minus 3. Nitride, that is minus 3. So again we will see other compounds where we can find oxidation number, which are very important to know the oxidation number of the difference, just like chromium, manganese in different compounds. Now you can see here the question number 3, that is calculate the oxidation number of manganese in below of the compounds. One is potassium permanganate KMnO4 and next is K2MnO4 potassium manganate. Now you can see first one KMnO4, that is potassium permanganate. Potassium is 1, manganese 1 and oxygen 4 times. That means let here X is the oxidation number of manganese and potassium, that is plus 1, oxygen, that is minus 2 into 4 minus 8. We know sum of all the oxidation number of the atoms in a compound should be equal to 0. That is why you can see here plus 1 of potassium and X for manganese minus 8 for oxygen. So it should be equal to 0 and X equal to plus 7. What is X? Oxidation number of manganese in potassium permanganate is plus 7. Second case, K2MnO4 potassium manganate. Now here potassium 2 times, Mn1 and oxygen 7 times. That is why you can see here potassium plus 2, X is the manganese and minus 8, that is for oxygen, is equal to 0. So X equal to here plus 6. That means oxidation number of manganese in potassium manganate is plus 6. You can find here the oxidation number of manganese in both cases remains same. Now next question, calculate oxidation number of chromium in different compounds. First one K2Cr2O7. K2Cr2O7, that is potassium dichromate. Potassium 2 times plus 2 and chromium 2 times 2x. X is the oxidation number of chromium and O7 7 times oxygen, that is minus 14, and sum of all values should be equal to 0 and X equal to plus 6. That means chromium oxidation number here plus 6. The oxidation number of chromium in potassium dichromate is plus 6. Next question, K2CrO4. What is K2CrO4? Potassium chromate. K2CrO4 means potassium chromate. And see here potassium 2 times, chromium 1 and oxygen 4 times. So it is minus 8 and here chromium X and potassium 2 times plus 2 and sum of all the values is equal to 0. That means X equal to plus 6. That is oxidation number of chromium is plus 6. These are the questions here we have calculated the oxidation number of different atoms. It is very easy, and here we see any question in any compound one can find the oxidation number of an atom. Next is, what is stock notation? Stock notation, first we have to calculate what is the oxidation number, either plus 2 plus 4 like this, and after that we will see what is meant by stock notation. Stock notation is very easy. It is only one representation, that Roman numeral, the oxidation number is represented by Roman numeral in parenthesis after the atom of the metal, or sometimes non-metals can be used also. That means here you should know what is Roman numeral for the oxidation number. Let oxidation number plus 2, you will use Roman numeral 2 in bracket. So let us example, stannic chloride, stannic plus 4. Plus 4, that means stannum has oxidation number plus 4. Then how can you represent SnCl4? SnCl4, here after Sn, here you will put Roman numeral 4 in bracket. And see here Sn in bracket 4 Roman numeral and bracket close, and here Cl4. So SO3, sulfur trioxide. What is the oxidation number of sulfur here? That is plus 6. So sulfur is not a metal, but for non-metals also we can use. So after sulfur, in parenthesis I have to put that 6 Roman numeral. So what is the formula now? S in bracket 6 Roman numeral, and after that O3. And next is cuprous chloride. Actually, cuprous chloride formula Cu2Cl2, because it always exists in dimeric form, so the formula should be Cu2Cl2. Then what is the oxidation number of cuprous here? +1. So we should write Roman numeral 1 in parenthesis. So Cu2 in bracket 1 Cl2. Then come to HgCl2. What is Hg? Hg means mercury. So HgCl2 and mercuric chloride. Mercuric means +2 oxidation number. Then how to put? Hg in bracket in parenthesis Roman numeral 2 Cl2. Now see, it is very easy. Then here cupric oxide. Cupric means +2 oxidation number. Then if it is +2, then how can we write that stock notation? Cu after Cu, and because there are 2 times Cu2, so you will write Cu2 in bracket or in parenthesis 1, then oxygen O. So Cu2 in bracket that is 1 and O. Then come to CuO. What is CuO? Cupric oxide. Cupric oxide, that means oxidation number of copper is +2. So I can represent here Cu in bracket in Roman numeral 2 and O. Cu in bracket 2O. That is cupric oxide. This is called stock notation. Stock notation is very easy, and easily the oxidation number represented by Roman numeral and after the metal atom. Now here oxidation number, what is meant by oxidation number, and what are the main difference between oxidation number and valency, and how to calculate oxidation number of any atom in a compound is clear to you, I hope. And the next is stock notation, also very easy. One should know Roman numeral, then one can write easily. I hope you will subscribe my channel B.L.DASH, short and sweet in chemistry. Also I hope you like and share my channel, and after this video and in coming video I will explain the types of redox reaction. Thanking you.